We're going to spend some time right now with a subject near and dear to my heart, and that is logging. And I'm going to give you a dad lecture just immediately. Please, please, please do not ignore your logs. This is deadly serious stuff. Because logs really are like a medical test letting you know that you're about to get really sick. Except in this case, it's your network that gets sick if you don't get the test results. And in many cases, you have to go read the test results. You have to go look at the log. Now, you may have some network monitoring tools that are looking at your logs or monitoring for that kind of thing, some yellow flags to let you know something bad is coming up down the road. But in many cases, you've got to go open that. And this message really goes for everything in networking, whether it's Microsoft, whether it's Cisco. I don't know how many times over the years I was called into sites where, something pretty bad had happened and the network was down, etc., or backups didn't run. That was a big one. And when you open the event viewer or the logs that they had for the different applications, you'd see little yellow flags almost literally all over the place. You need to look at this drive, you need to look at this drive, you need to look at this, etc. And they had just never been looked at. So please, whatever programs you've got creating logs for yourself, make sure to read them. Make sure to use them. Now, let's talk about Cisco logging in particular, because we can actually send our Cisco log output to a couple of different places. We can send it to the console. We can send it to the buffers. We could send it to the VTY lines or to a server, either a syslog server or a simple network management protocol SNMP server. Now, in lab environments, I personally will just look at the buffers most of the time, and that may be something you do as well, but there are some serious drawbacks to looking at the buffers when it comes to production networks. Namely, the big one is that you lose the buffered log messages when you reload the router, and that may not be what you want to do. Or someone else does, you lose power, anything. If the router goes down, you're going to lose your buffer messages. Now also, the buffer is only a certain size by default, and while you can make it bigger, it seems to me it's just easier to end up with overwritten log messages when you're keeping them in the buffer than, say, on a server. And the problem is when the buffer gets full in Cisco, what'll happen is the log will be overwritten with the oldest log entries being overwritten first, which makes sense. But again, it's easier to lose your logged messages. Now, before we start looking, I've got a little lab here for you as well, and something to do with some timestamps I definitely want you to see. But before we do, remember all these logging levels that you had to memorize in your CCNA studies? It's a good idea to know them, and this is just little descriptions I came up with because, to some people, to most people I think, alerts and critical and errors and notifications all sound kind of alike. But starting at message level or logging level 0, which is the worst, that's emergencies. You're in a lot of trouble already. Level 1 is alerts. You really need to take care of this now. Level 2 is critical. This is really important. Level 3, errors. You should know about this. Level 4, warnings. Hey, did you know about this? Level 5, notifications. Hey, look at this when you have a moment. It's important, but it doesn't need immediate attention. 6, informational. Hey, isn't this interesting? And 7, of course, our favorite, debugging. Wow, a lot of stuff goes on behind these commands, and we all know that's the deal with debugs. So I don't know if you can make any kind of little memory thing there where you can remember it just looking at the first letters here, little acronym, but it's a good idea to know these logging levels, and you can see them on Cisco routers as well. And one thing that we're going to see in action in just a moment refers back to something we talked about earlier in this section, and that is the correct time. Whether it's network time protocol or something else, and frankly it's probably network time protocol, if you choose date and time timestamps, which I personally like to use, make sure that your router has a highly reliable time source, because if you don't, that could get really, really confusing. Again, you're going to see in a moment just a small example of why it is so important for our routers and switches and all our network devices in our network to have a synchronized time and a highly reliable time source. Here's what I wanted to show you right now, and we've got 3 different kinds of timestamps here to go with our messages, and I'll show you some more logging messages, things you can do here in a moment. But show logging is the one I ran here early. You'll notice this is the default size on this router, 4096 bytes. And it's going to show you, syslog logging enabled, console logging, monitor logging, what you're logging to your buffer, and then your trap logging. And notice that I've got debugging here for most of the levels. And you want to be really careful about that in production networks because, again, some of you know what I'm going to say here. I definitely don't mean to scare you off running debugs, especially in a lab environment, because it is a great way to see what goes on, as I say, behind the command. And it's a great way to learn. And that's the one thing, not the one thing, but one thing I wish someone had told me when I was going after my CCNA, my CCNP, and so forth, is to use a lot of debugs when you're first learning this stuff. But you need to do it on lab networks because they're very CPU intensive, all debugs, especially certain debugs like debug IP packet. You get a ton of information. It's not something you want to practice on a production network when you think nobody's watching. Okay, it's just not. Take it from me. I've actually seen in lab environments that I've run, I had a debug IP packet running, or a student ran it in a live lab, and wham, the router was actually overwhelmed. We could not interrupt it. It was giving us so much information. We could not say, you all, stop, undebug all, undebug all. So it's just something to watch out for here as well, because it can fill up your logs very quickly. It's a lot of information. So let's take a look at what happened here when I brought this router back up, because after this, after I ran show logging, it's going to show you the contents of the buffer. And notice the timestamps here. We've got some odd ones there. Then they changed to this, to March 1st, and then followed by a clock. And I can tell you that it's officially November now when I'm recording this. And down here, they changed to November 2nd. And what happened here is I started playing with the timestamps first and then with the clock. Because by default here, what I got is the timestamp since the system up time. So the system had been up for 43 seconds when these events occurred. And then what I did is use the timestamps command. I'll definitely show you that in a moment, to change that to a calendar time. And you could see that, but the calendar wasn't right, so I went in and changed the clock to November 2nd. I did that manually instead of setting up NTP again, and then I got these timestamps. So now if I do something like closing, let's see, let me just close that interface. I know a little of this will be off the screen because I try to use the largest font I can for these. And you can see here I'm getting like calendar dates instead of like something that would be from system uptime. And there's your link 5, there's your numeric value right there in the middle. And it's just telling you, hey, this is down. And what level is that? What level is 5? Remember that one? It's notifications. And that falls into the category, hey, look at this when you have a moment. It's not vital. Or not going to bring the router down, anything like that. And then if I just do a no shut, we'll get messages right after that as well. We certainly should. But notice the different timestamps. When I'm in a lab environment, I like to have the date time timestamp. Some people like the system uptime. That's fine. There's no right or wrong answer. But I want to show you how to fine tune the timestamps. Let's see what we're seeing at the top of the config. Do we see anything as far as... Okay. Here we go. This is what I configured, because you may not see this at all, because service password encryption is one of the few you'll actually see in the config when it's been turned off. But notice service timestamps, debug uptime, and then log date time. Let's go ahead and take a look at these options. This is good stuff to know. And it's going to be a service. And you don't need to know all of these, but some of them are actually security issues that we'll likely mention, if not in this course, then definitely in your NP security course. Courses, I should say. But right now we just want to adjust the timestamp, and it's timestamp debug / log messages. And let's look at our options. So are we going to configure something here for our debug messages or our log messages? So let's say that it was going to be for the log messages. And I could just hit it right then and there, and what I saw by default was, timestamp with system uptime. But if you want that date time, you can just enter it like that. And then it's going to even ask you, do you want to use the local time zone? Do you want to include milliseconds in the timestamp? I usually don't do that, but you're welcome to do that if you want to. And then whether you want time zone information added to the timestamp. So a lot of options there, but just be aware of that. Again, it's a good sign, or excuse me, it's a really good example of why time is so important in our network, synchronized time, because having been there, if you're going from one router to another and the timestamps are all screwed up and you're trying to figure out what's going on, it can be pretty difficult to do so. So that is it. Let's see, let's do that show logging again. And again, there's your log buffer size. If you wanted to change that, I believe it's, let's get out of that. You've got your options right after logging. And here's of the logging host. So if we're sending it to a server, we could put it right there. Then if you just want to change your buffer size, your console logging level, if you wanted to say how many events you wanted kept in your history table, etc., your monitor logging level, then your source interface, specify interface for source address and logging transactions, and then finally trap, which is our syslog server logging level. It's not easy to say. So a lot of options here. And if you get the chance with your own router or GNS3, whatever works for you, going through yourself and going through each one of these options is a good idea. It's a good way to keep them in your memory. But again, just in the real world, it's important to have all these values set, but the really important thing is to monitor your logs, because you're going to get some vital information there. So I'm going to stop the video on this one right now, and then we'll call up CCP at the beginning of the next video, and we'll look at how we can work with logging in there. See you there.